This is a solution to problem number 53, and after that I'll do problem number 59 from homework 7.2. So in 53, it says to use cofunction identities to evaluate the expression without the aid of a calculator. So for the cofunction identity, we know that sine squared 25 is the same thing as cosine squared of the complementary angle. So the complementary angle to 25 degrees is 90 minus 25 degrees, which is 65 degrees. So I can substitute here, instead of sine squared 25, I can write cosine squared 25 degrees. So I have cosine squared 25 degrees plus, oh, I'm sorry, not 25, cosine squared 65 degrees plus sine squared of 65 degrees. And this is the Pythagorean identity, which says that sine squared theta plus cosine squared theta equals 1 for any value of theta. So 65 degrees would qualify here. So this value is 1. Now let's take a look at number 59. In number 59, we're supposed to verify if, actually the statement says the equation sine squared theta plus cosine squared theta equals 1 plus tangent squared theta, because they're saying that's an identity in the textbook, because sine squared theta plus cosine squared theta equals 1, and 1 plus tangent 0 squared equals 1. Okay, so that's a particular value of theta. So that would not be an identity. So I've written here false. An identity is true for all values of theta in the domain, not just for a particular value. So we can disprove this identity with one counterexample. The counterexample that I chose was to let theta be pi over 4. If we choose theta equals pi over 4, then we can substitute that in, and we'd get sine squared pi over 4 plus cosine squared pi over 4 should be equal to 1 plus tangent squared pi over 4. Sine of pi over 4 is rad 2 over 2. Cosine of pi over 4 is rad 2 over 2. And tangent pi over 4 is 1. If we think back on the unit circle, I'll justify those values. Pi over 4 is the angle here, and the x and y values on the unit circle are rad 2 over 2 and rad 2 over 2. So rad 2 over 2 squared is 2/4, which is 1/2. And so we'd have 2/4 plus 2/4, or 1/2 plus 1/2, which is 1, which is not equal to 2. So that means that this is not an identity.